it is visible.
Okay, great. Okay, so let's start. Myself, Shubham Gurde. I'm from ISI India, and today we are going to see EV motors and its calculation. So, as we all know, that electric vehicle is a booming industry all over the India. So, the main parts in electric vehicle used are like battery, controller, and motor. So, motor is one of the major parts used in used in electric vehicles, and it's a very essential part for the drivetrain, right? So today we are going to see EV motors and its calculation. So these are the things we are going to learn today. We are going to see what is the motor, types of motor, working principle of motors, and calculations. We are going to see from the very basics of the motors, right? Or what are the laws that is being used in motors and its applications. So what is an motor? So motor is nothing but electric motor is used to convert electrical energy into mechanical energy, right? So electric motor is just an device which converts electrical energy into mechanical energy. Just like our bulb. What does a bulb do? It converts electrical energy into light energy. So like motor is the thing or a device which converts electrical energy into mechanical energy, because we can't run our electric vehicle with just with the help of battery, with just help of electrical energy. We need mechanical energy to rotate that tires, that drivetrain, right? Whichever gears which are present inside that gearbox, we need to run those things, and those all are the mechanical parts. So we need to convert electrical energy into mechanical energy. So most electric motors operate through the interaction between the motor's magnetic field and electric current in the wire winding to generate the force in the form of torque applied to the motor's shaft. So what does a motor do? It operates on the interaction between the magnetic field. So we all know that there are two poles, right? North pole and south pole. So there is an invisible or the imaginary force acting through the north pole to south pole. So whenever an electric wire or a current carrying conductor is passed through that magnetic field or varying magnetic field, so the force is generated on that wire, right? So it's like a torque. So whenever that current carrying conductor or electric current wire winding is overlapping that magnetic field, so the torque is applied on the motor shaft. So electric motors can be powered by direct current DC sources such as from batteries or rectifiers, or by alternating current AC source such as power grids, inverters, or electrical generators, right? So we know that there are main sources of electric current, that is DC and AC. So electric motors can be powered by both direct current as well as alternating current. All right. So we get direct current in the form of batteries or rectifiers, which we are mostly using in our electric vehicles. So we use we use batteries in electric vehicles for driving the electric motors. And for other applications like our household fans or any other type of industrial applications of motors, so we use their power grid inverters or electrical generators there, right? So what are the main types of motor? So there are different types of motor. So in electric motors, mainly DC motor, AC motor, and other motors, or we as well call them as special motors. Okay. So in DC, we can see that the DC shunt motor. There is DC. These motors can be directly operated with the help of direct current or like a battery, or we can directly power them from an rectifier. Okay, so DC shunt motor is an example of DC motor, Again, the separately excited motor and series motor. PMDC motor, also called as permanent magnet DC motor or direct current motor, and compound motor.
So
When we talk about AC, in AC,
sir?
Yes.
The slides are not changing. It is in the first slide now. Now it has changed.
Okay.
Now it has changed.
Okay. Shall I go through once again? So see, these are the things we are going to learn today. Are the slides visible and changing now? Hello?
Yes, it is visible.
Yes. Are they changing as well?
Yes.
Okay. So these are the things we are going to learn today. We are going to see what is motor.
Sir, you are muted.
I think you are muted.
Okay. So what is motor? Motor is an device which is used to convert electrical energy into mechanical energy. Okay. So in electric vehicles, we are using battery as a power source. So from that battery, we are getting electrical energy, and we need to convert that electrical energy into mechanical energy. So how can we convert that? It's like a motor. As we are using internal combustion engine in petrol vehicles, right? Or fuel vehicles, diesel vehicle or petrol vehicle. So what that internal combustion engine is doing, it's converting chemical energy from the petrol or diesel, whatever fuel we are using. So what is that internal combustion engine doing? It's converting petrol to mechanical energy, chemical energy from petrol to the mechanical energy. And that mechanical energy is transmitted through the transmission to the wheels. And then we are able to move our vehicle forward. Same like that, what we are using here, we are using electric motors in electric vehicles. So we are converting electrical energy from the batteries to the mechanical energy through the motor, and then we are transmitting it through the transmission line, transmission gearbox and axles, and then we are able to run our motor, our vehicle, right? So most electric motors operate on the interaction between the motor's magnetic field and electric current in the wire. Okay, so as we can see here, there are two poles in the magnetic field, north and south. So I'll just go through the first two slides shortly, so you will be able to recall that. So what we are doing here, we are having two poles, north and south, and there is an imaginary or like invisible force acting besides them or throughout the magnet, right? So whenever an electrical current carrying conductor is passed through that magnetic field or that varying magnetic field, so force is applied on that, or the force is generated on it. So in the form of torque, we can convert that into the torque. That force is converted into torque, so that our motor shaft is able to rotate. So from that motor shaft, we are gathering or we are acquiring our mechanical energy. That motor shaft is connected to our transmission, right? So electric motors can be powered by both direct current as well as alternating current. So there are DC sources like batteries and rectifiers, and there are alternate current AC sources like such as power grids, inverters, and electrical generators. So in electric vehicles, we are mostly using batteries as an power source. So we mostly use and DC source electric motors there. And for our household applications or like industrial applications, we are using AC motors. Okay. So these are the types of motors. Electric motors come in the various types like DC motor, AC motor, and other motor, also known as special motors. Okay. So as we can see on the screen, the DC motors are DC shunt motor, separately excited motor, series motor, PMDC motor, right? So it's also called as like permanent magnet direct current motor. It's also mostly used in electric vehicles. Again, we can see that compound motor. In AC motors, we can see that induction motor and synchronous motor. Again, electric motors is like very big topic. It's like an subject in itself. So if we talk about the induction motors, there are again the single phase motors and three phase motors. Again, in induction motor, there are like squirrel cage motor or slip ring motor. So there are different types. Again, in synchronous, asynchronous, there are n number of motors in AC motors as well as DC motors. But if we talk about other motors or special motors, there are stepper motors. Stepper motors are used where we need this precise movement of the rotor, or where we need an angular movements. So if we need to rotate our rotor in the 90-degree or 45-degree or 60-degree, so stepper motors are mostly used that in like an industrial or robotic applications. In the robotic applications, the stepper motor is mostly used. Brushless motor. So brushless motor is mostly used in electric two-wheelers. So here we are using brushless DC motor, right? So it's like the rotor is made up of permanent magnets. We are going to see that brushless DC motor in detail in the further slides. Again, the hysteresis motor and reluctance motor and universal motor. And nowadays, the combination of some motors like compound motor, if the compound motor can run on DC as well as AC. Again, we have nowadays we have combined the brushless DC motor with the reluctance motor, right? So or the synchronous motor, right? We have made a new motor called as PSM motor, permanent magnet synchronous motor. So it's like most preferable motor used in electric four-wheelers like Tesla, because it's highly efficient and the torque whatever is generated is it's like very linear and very good quality. So these are some motors used in electric vehicle. These are the most used electric vehicle motors. Brushed DC motor, BDC, also known as BDC. Brushless DC motor, BLDC. The BLDC motor is mostly used in electric two-wheelers, right? So there are again two types in brushless DC motors. One is mid-runner motor, or also called as in-runner motor, and another one is hub motor, right? So we are going to see those things in detail. Induction motor, as I have told you earlier, there are again two types of induction motor: three-phase induction motor and single-phase. So three-phase induction motors are mostly used in the industrial applications, or where the heavy load is needed. And the single-phase induction motors are mostly used in household applications, just like our fan or water pump motors, like that. Again, I've told you about the PMSM motor, permanent magnet synchronous motor. It's like most preferable inside the electric vehicles due to its high efficiency and compactness. Next one is switched reluctance motor, SRM. It's also used in some of the electric vehicle. So first of all, we are going to see brushed DC motor, BDC. So as we can see here, this is the circuit or the internal structure of the motor. So as I have told you, here is a north pole and here is south pole, and there is an force acting across this, right? So there is magnetic field passing through north to south. Okay, and we have placed an conductor here. As we can see in this blue line, this is an conductor. So what we have done here, we have applied an battery. As we applied a battery, the current is passing through this commutator, right? So what is commutator? Commutator is converting or it's like just like a junction, so that even if this rotor is rotating, the electrical supply is going to the winding, right? So there are graphite brushes. So as we can see here, the positive terminal and negative terminal. So current is flowing in this direction. Okay, current is flowing in this direction. So as the current is flowing in this direction, the magnetic field which is applied here is cutting this this electrical wire, right? This electrical wire is cutting this magnetic field. That's why what's happening here, the force has been generated here. The upward force has been generated. As the upward force is generated, again the commuters, this ring will come here and this ring will go there. So current will flow in alternate direction, right? Current will flow in reverse direction. So the main work of the commutator here is to convert this DC into AC, so that the reversal of current will be going on. So as the reversal of current will going on, there will be opposite directions applied here, so that it will get an torque. The torque will be generated, right? So as the torque will be generated, it will come to the rotating position, right? So these are the some internal main housing of the DC motor. As we can see, this is the main housing. Okay, this is our rotor. Here are the permanent magnets. This black we can see here, these are the permanent magnets which are placed on the stator, and this is the iron core. This is the stacking done here. It's called as stack. All right, these are the small plates. This is the commutator, and these are the windings. These windings are occupied on the iron core rotor, and these are the electrical connections. Here the brushes are there. Here the brushes are there, and this is the whole body, so that all the internal parts are stacked together and they remains connected. And here the bearing is there. Okay. So what is the principle of electric motor? An electric motor or DC motor works on the principle that an electric current is passed through a conductor placed normally in magnetic field. A force acts on the conductor, as the result of which the conductor begins to move and mechanical energy is obtained. Right. So what's happening here? The current is passed through this conductors, right? This coil. This is called as winding. This is called as rotor winding. And we are applying the magnetic field from the stator. So whatever the magnetic field is generated here, it's cutted by this current carrying conductor. And as this current carrying conductor cuts this magnetic field, the electromotive force is being generated here. Magnetic field, due to this magnetic field and this wire, the EMF is being the force is being generated here, right? And the motor will start running. A simple DC electric motors, when the coil is powered, a magnetic field is generated around the armature. As I've told you, the left side of the armature is pushed away from the left magnet and drawn towards the right, causing the rotation. The rotational energy will be obtained here. The armature continues to rotate. As the armature is continuing to rotate, it will try to align horizontally. When the armature becomes horizontally aligned, the torque point becomes zero. At this point, the commutator reverses the direction of the current passing through the coil, right? And the reversing the magnetic field. As this rotor is rotating, the whatever the coil, the current which is passing through the coil, it will get reversed because of this commutator, right? So I have told you the DC is been converted into AC due to this commutator, and this process will repeat until we disconnect the power supply or we cut off the power supply. This process will be keep going on. First of all, the current will flow in this direction. In another point, at another point, the current will flow in reverse direction. So what will happen here? It's like an alternating current, and the magnetic field will keep changing on, which will cause the rotational motion here. So these are the different types of electric DC motors: separately excited motor, shunt motor, series motor, and cumulative compound motor. It's also called as compound DC motor. So as we can see, this is A, armature. Armature means our rotor, and this is our field winding. So as we can see, we have applied a voltage V, positive and negative terminal. We have connected this to armature, means the rotor, and this is our commutator here, right? And the negative terminal is connected to the A2 point, A1 and A2. And here we have connected the field winding from the VF. We have applied VF to the field winding. We can see here IA is running through the armature, means the current A is running through the armature, and current F means IF is running through the field winding. This will interact, and it's our separately excited motor. Why separately excited? Because whatever excitation we are giving here, it's separate, right? But what happens in shunt? Connected the field winding parallel here. Whatever voltage has been applied to the armature here, with the armature to parallel to the field winding, we have connected this. A1 is connected to the F1, and we have connected this to the positive voltage. Same here, A2 is connected to F2, and we have connected to the negative voltage. And current IA and IF will be running through them. The current IA will be running through the armature, and current IF will be running through the field, means the stator. What happens in series? In series, the V is connected to the armature, and in series, the field winding has been connected here. So whatever current will be flowing through this field winding, same current will be flowing through this armature winding. So as we applied load here, whatever current will be withdrawn by this armature, that much current will be flowing through this field. And in cumulative, what happens? Compound motor, we are connecting both shunt and series. We have connected one field winding in series and another field winding in parallel. So here, whatever current will be going through this V, it will be divided into IA as well as IF. So some current will be flowing through here, some current will be going through here. Whatever current will be flowing through this S1 and S2, the same current will be flowing through the armature. This is our series winding and this is our parallel winding. Thus, it is called as compound motor. I hope you are getting me. So we can see this is the BLDC motor. So how the BLDC motor operates, we are going to see. That was about the earlier motors were about brushed DC motor, and next is BLDC motor. So in earlier we have seen that there was commutator, right? Just let me see this commutator. So what happens due to this commutator and these brushes, there are lots of losses occurred here. Okay, so due to this commutator and brushes, there is the sparking happens. Again, the frictional losses gets increased. Again, the wear and tear of brushes are also there. So we need to replace those brushes again and again. Again, what happens when it's rotating and due to that sparking, the heat is generated. And when that heat is generated, we need to cool that commutator. So we need to cool that commutator. For cooling that, we need to give some holes there or some opening there so that the commutator is being cooled. But in electric vehicles, if we use these motors and if there is any kind of gap there, so water will enter or the dust from the roadside will enter to that commutator and inside motor. So obviously the efficiency will reduce. There might be some short circuits or anything might happen there. So what we need to do here, we need to remove that commutation there. So in BLDC motor, what's happening? The stator will be wound with coils and brushes are absent, right? So the stator is wound with coil. As we can see, the coil is wounded here with the stator, and the rotor will have permanent magnet. So this rotor will rotate and we'll connect our wheels to the shaft, right? And the Hall effect sensor is connected to the rotor. There are 3 Hall effect sensor connected to the rotor to detect the rotor's position. At what position north is there, at what position south is there. So the permanent magnets which are placed on the rotor, we need to define the rotor's position. So to defining that rotor's position, we are using Hall effect sensor here. So as we can see, the BLDC motors advantage, it's having high torque and efficiency as well as high power. BLDC motor, right? So this is our permanent magnets N and S, and this is our rotor coil, stator coil, right? So as we can see, A phase, B phase, and C phase. These 2 windings will be acting at the same time. We can see this phase AB, BC, and CA respectively. This is the external commutation of BLDC motor. So how the external commutation of BLDC motor works, we are going to see. This is MCU here. So this MCU is nothing but microcontroller unit, and here the driver is there. These are the MOSFETs. So what's happening, BLDC motor, we need to convert that DC direct current into 3-phase AC, right? Into 3-phase AC, alternating current or pulsating DC. As we can see here, this is the pulsating DC. The trapezoidal waveform has been formed here. So this Q1, Q3, Q5, Q0, Q2, and QC, this MOSFETs will be working here to convert the direct current into alternating current or direct current pulsating DC, right? So DC will be converted into AC or pulsating DC, whatever. So this A phase and B phase and C phase, these are the coils here, right? A, B, this B coil and this B coil, C, this C coil and C coil. In this kind, the star connection is done here, right? So we don't need, there is no need to give neutral here because it's already 3-phase connected in star connection. And how to detect this rotor position, right? So this Hall effect sensor will be giving signal to this microcontroller unit, and this microcontroller unit will compute the things which are the signals given by the Hall effect sensor, and it will turn on this MOSFETs accordingly. So if A sensor is been activated, so it will turn on this A and B phase. If B is activated, it will turn on B and C phase, and C is activated, it will turn on C and A phase. This kind of trapezoidal waveform will be generated here, and this is also known as external commutation. Whatever the working the commutator was doing there inside the brushed DC motor, same the commutation is done here with the help of power electronics. So this is the advantage of BLDC motor, because we are recovering that energy, whatever the losses were occurring inside the brushed motor due to those brushes, commutators, the inefficiency was occurring. That inefficiency is being eliminated in brushless DC motor. So there might be some disadvantages in BLDC motors, like magnets may be costly or the cost of sensors. But in electric vehicles, the BLDC motors are most preferred due to their advantages like high torque, efficiency, and high power. Again, the smooth control of BLDC motor is also achievable with the help of controller. So as we can see, there are 2 types of BLDC motor. One is outrunner, or also known as hub motor. So here stator is inside the rotor, right? This is our stator and this is our rotor. We can see in this electric vehicle also. So what happens here? The tire or the wheel is been directly placed on this rotor. We can see this white lines here. This is the hub motor. This is the hub of the motor. And we have placed directly wheel on this hub. And this is our stator. So what's happening here? The advantage is, if you can see, we have saved lots of space here, right? But due to the restricted power, due to the dimensions, the power has been restricted because it's not able to generate the lot of torque here. It's not able to generate the lot of power here. We can't use it for high power applications like in electric bikes. It's mostly suitable in electric scooters. It rotates slow, but it is having high torque. Okay. Even it's very compact. So in electric scooters, they are mostly preferred due to this, due to their compactness, and also they are easy to maintain. And again, the efficiency of them is very high, and they are mostly used in Hero Electric and Okinawa. Rotor is inside the stator. So in runner motor, what's happening here? The rotor is inside the stator. As we can see here, this is our stator and this is our rotor. So what we are doing here? The rotor is the rotor. There is shaft. On this shaft, we are attaching some pulley or gear, and that gear or that pulley is connected with the tire with the help of transmission belt or chain, right? Same as in our electric bike, in internal combustion engine bikes. So with the help of chain or with the help of belt, we are connecting that shaft of the internal motor with the tire. So it gives good speed because it's having higher starting torque, and even it's more powerful than the hub motor. It's withdrawing high power. So because of that, it's giving us good speed. All right. Again, here we need some extra components to supply the power to the wheel. Again, the assembly is a bit complicated here, but it's used in some of the electric scooters and mostly used in electric bikes, right? So this is used in Ather. Next one is permanent magnet synchronous motor. So as we can see here, the permanent magnet synchronous motors connection is construction is given here. This is mostly used in electric four-wheelers, right? So as we can see, this is the internal construction of the motor. So here we are having stator core, right? This is the stator core. This is the bound bar wound wire. On the stator, we have wounded the wire here. This is the rotor hub. So here what's happening? Here we are using the synchronism as well as the permanent magnets here. As you can see, we are using the permanent magnets here. And this is the bearing support assembly. And you can see these pipes. These pipes are for water cooling. The water will be flowing through these pipes. This will be the inlet and this will be the outlet. The water will be flowing through this pipe so that the heat management of this motor will be great, right? Due to this thermal management, the heat losses will be occurred very less. So as we can see, the permanent magnets are being placed inside this with the in the form of V shape. There are also two types of PMSM motor, permanent magnet synchronous motor. In one motor, we are placing this permanent magnets in this way, and in another way, we are placing them in the outside part directly, right, parallel on the rotor itself. So as we can see, again here are the two types of PMSM motor. In one motor, in first one, the rotor is inside, the permanent magnets are placed inside, and the stator is at outer side. And if we can see in this another motor, the rotor is at inner side, the stator is at inner side and the rotor is at outer side. So as we can see here as well, this is the winding and here are the permanent magnets. And in this case, the hub motor or outrunner motor. So the stator is at inner side and the rotor is at outer side. So again, we need some external commutation, or we need some power electronics to power this permanent magnet synchronous motor. We can't directly connect our battery or power source to this magnet, to this PMSM motor and make it run. We need some power electronics there. We need controller to speed, to control the speed, to control the torque. There are various types of techniques used there. So here we can see the difference in PMSM motor, BLDC motor and induction motor. So in PSM motor, we are using the source of alternating current. Again, in BLDC motor, we are using the source direct current, and in induction motor, we are using the source alternating current. The back EMF generated in PSM motor will be sinusoidal. The in BLDC motor, it will be trapezoidal, and on IM, it will be sinusoidal. In PSM motor, the torque is high. Torque is high because there is no repulsion. There is a very low back EMF generated. Again, in BLDC motor, the torque will there will be torque. The torque will be high, so the repulsion is also less, right? But in induction motors, what happens? The repulsion is high at the starting, but the torque is high at this after the induction motor gets in running, right? At initially, the torque in the induction motor is less as compared to BLDC motor and PSM motor. But when the induction motor gets into running, or it's get into the synchronous speed or asynchronous speed, the torque generated by the induction motor is very high. The power will be high in the PSM motor. In BLDC motor, it will be low, and in induction motor, it will be less. The rotor are the permanent magnets are used so that the high torque and smooth run, it will provide a smooth running. Again, in BLDC motor, we are using permanent magnets so that it will produce the high torque and it will give us the smooth running. In induction motor, as a rotor, we are using iron or ferromagnetic materials. Like in case of squirrel cage induction motor, there are no magnets used there. Or in case of slip ring motor, we are just using the coils there. Okay. The speed is constant of PSM motor. We can even if we are applying some load up to certain condition or up to certain levels, it will keep its speed constant. Again, in BLDC motor, it will keep its speed constant under the some circumstances. If we are providing it good current and good power there. And induction motor, as we will increase the load, the speed will get decreased, right? Sorry. Okay. So we are going to see some calculations here. So in electric motors, the power consumed is given by I into V. So we all know the power input given inside the electric vehicle is calculated as I into V, means the current into voltage, where we can see the input power is measured in watts, right? So we denote the power in terms of watts, and current measured in amps, voltage V applied measured in volts. So this is current flowing through the motor, and voltage V applied to the motor, and it will give us the power. The motor is supposed to do some work, and two important values define how the powerful the motor is. It is its speed and its torque. The turning force of the motor, the output mechanical of the motor could be calculated by using this formula, right? So we can calculate the P out, the power out, using this formula, T into omega, or speed, where the P out is equals to output power, which is measured in watts. The T is equals to torque measured in Newton meters, Nm, and omega or W is known as angular speed, which is measured in radians per second, right? So we can we can easily calculate the angular speed if you know the angular speed of the motor in RPM. So we can get this RPM easily with the help of tachometer. If we'll use tachometer, we'll get the RPM. And to find, so here omega will be RPM into 2 pi upon 60. Okay, so RPM is equals to 2 pi upon 60, and if where the angular speed measured in radians per second, RPM is rotational speed revolutions per minute. Pi, we all know the value of pi in mathematical constant, 3.14, and 60 is the number of seconds in the minute. In this way, we can calculate the power, output power, omega. Okay, so I hope I have cleared the PPT in a good manner. So audience is open for the questions. If anyone is having some kind of doubt or any kind of questions, please come forward, or you may ask.
If anyone having question, please ask.
Yes, sir. You see, in the BLDC, you mentioned that, that commutator is removed. Means stator and rotor is there. The stator is also having bindings as well as the rotor. Rotor is also having some binding to become. There is no, I think, permanent magnet.
Yes.
Then you told us that that the inside is stator and outer ring is inside is that is a stator and outside is a rotor. How the casing will be there? Casing is always a fixed one, no? Then inside that rotor which moves, the shaft, how the energy is just taken, converted mechanical energy.
Right. So let me just go in the back.
Yeah.
Okay. So see, you can see this. Yeah. So this is the rotor, right? And this is our stator. You're talking about this, how the casing will be stabilized and the outer part will move.
Yeah.
Right. So whatever the stator is, whatever the stator's the casing will be there, it will be mounted on this axle, right?
Yeah.
Right. The in this motor, if we can see, this is the outer part, and the stator inside this will be mounted on this axle, So this axle will be constant, which will be fitted to our vehicle's chassis, and the motor will, the tire will run freely, just like on our bicycle, like our bicycle's tire, right? So the axle is fixed, the outer part is moving.
Okay. So outer part is moving, but it's a motor, no? Because it has to be connected with the then wheel, no? Our wheel itself is just functioning.
Yes. The wheel will be placed directly on this rotor only.
Okay. Then problem.
Yes.
That is what I was just wondering how the fixing or attachment is there.
No, it will directly fixed on this motor only. Right. The wheel will be directly attached to one motor.
Then there will not be any problem. Okay. Thank you.
So the wheel will be attached to the rotor, and the stator will be attached to the chassis of the vehicle. Is it so?
Yes. Exactly.
That is fixed.
Okay.
You have already given the example of cycle. Yeah, cycle always the axle is fixed, and then cycle is rotating over that. Okay. From my side, thank you very much for giving such a good, elaboration about this BLDC motor and commutator DC motors.
Hello.
Yes.
Hello.
Yes, you're audible.
Hello, sir. I am Dr. Arvind Kumar.
Yes, sir.
I am Dr. Arvind Kumar. I actually want to know that will you issue some certificate, sort of certificate for attending this webinar?
Yes, it will be provided. Kindly contact on the given numbers on screen, or you can mail as well.
Okay. Thank you so much.
Always link is provided if you just give feedback. I think that link itself helps.
Yes. Any other questions?
Sir, hi sir, I am Aditya.
Yes.
Sir, I have a doubt that sir, there is rated power and peak power for electric motors. Why the motor can't run at peak power for a longer period, sir?
Okay. So as we all know that the motor is a device which is withdrawing current from its source, right? So whenever the current is flowing through the conductor, and when it is at its peak, the maximum number or high amount of current is flowing through that conductor. And when the current is flowing through that conductor and it's reacting with the magnetic field, the high amount of heat is being generated there, right? Again, while it's rotating on the high RPM, the frictional forces or the losses will be increased there. And in that case, due to that heat generated on that coil or that winding, or the heat generated due to that friction, so it will get like in some cases what happens, the heat increases so much at the peak power or at the peak load that it burns that winding, or it melts down that winding, or it tears down the insulation of that coil of that winding. So it's very risky, or the heat which is been generated at the peak power or at the peak or at the high, if we'll run our electric motor for the longer period of time at the peak power, so due to these heats, our motor might get burned, or there might be some short circuits, or there will be some maintenance inside our motor. So that's why it is suggested that we should use our electric vehicle, our motors at the peak for the lesser amount of time. I hope you got cleared.
Yes, sir. But in case of liquid cooled motors, sir.
In case of liquid cooled motor, so it's they are stabilized. They are more stabilized than air cooled or whatever the fins we are giving to normal motors. In that case, we can use them for the longer time at the peak power. But still, it's not suggested. If we extend some limits or if we cross some kind of limits, it might tear down the internal insulation of the motors. We can use liquid cooled motors at the peak power for the longer period of time. But still, if we need to protect our motor, or if we need to make our motor more efficient, we should run it in the given criteria only.
Okay, sir. Thank you so much for your valuable insights.
Yes. Any other questions?
Sir, can you please throw some light on the working of the... Hello, am I audible, sir?
Yes.
Can you please throw some light on the working of the BLDC motor?
I think there is some network issue.
Some disturbance is there.
I think there is some network issue.
Yes. Yes, sir. There is one also big issue while filling the feedback. It is showing wire harnessing. I think last week it was start. So is not feedback is not relevant with the current today's session. It is connected with the last week harnessing, wiring, and all those things are there.
Okay, sir, we will update this.
Please update. Though I have already filled it, but the title is written last week.
Hello. Hello, am I audible?
Yeah, yes, sir.
Yes. So the question was the working of BLDC motor, right?
Yeah, yes, sir.
These are the permanent magnets, neodymium magnets, mostly used in this. These are placed on the rotor. This, let's say, this is north and this is south. They will be placed always in alternating directions. If this is north, this will be south. If this is north, this will be south, right? And this will be our stator. So even in this stator, we will be creating electric magnetic field, or with the same principle like electromagnets, the magnetic field will be created electrically here by supplying the three-phase alternating current here, right? So whenever this rotor will be placed inside the north, and if the magnet will be made south, it will get attracted. And let's say if this is north and another magnet of this stator will be made north, so what will happen? They will repel. So they don't have any other direction to move. So what will happen? This rotor will get the rotational speed there, right? So it will get rotating. So while it's rotating again, because it's alternating current, this front magnet will be turned into south, then it will attract to the north of the rotor, and again later on it will turn into the north so that it will repel that rotor. So in this direction, in this way, the rotor will get rotating. And how the controller will know when to make this magnet north or when to make this magnet south? With the help of Hall effect sensor. So that Hall effect sensor will tell the controller, as I have told you. Just a second. So this Hall effect sensor will tell the controller when to make this coil north or when to make this coil south. You can see here.
Yeah, yes, sir.
Right.
Thank you, sir. Thank you.
Okay. I hope I have cleared all the questions and all the doubts of the audience. With this, I end the today's session. Thank you very much.
Thanks, learners, for attending the webinar. I hope this webinar helped you out to upskill your learning and skills. I would like to take the opportunity to introduce our company ISI India products and services that we offer in EV technology with small video. So have a look, please.
Hello engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship, to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industry projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling, and upskilling, at engineering institutes across India, we are setting up a state-of-art facility center of excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This center of excellence is not only limited to educate the students, but also it will be utilized for research, innovation, and product design and development. It is a combination of 6 labs, including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab, and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Very much thanks, learners, for watching the video patiently. So, any of you want to enroll in the courses, kindly send us inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you, everyone, for joining.